Well, now we've got something special for you this evening with Earl Hackett. Earl is a really knowledgeable 3D designer, printer, and he's agreed to do a build along with the people on the show, where what we're going to do is he's going to talk about a 3D program that you can download for free. He is going to take it step by step with you so that you're able to actually produce parts on that 3D program. And then we're going to talk about getting them printed. And then Earl is going to actually build the model of a bridge using the 3D parts that he's designed. And part of the build along is hopefully you're going to produce the same parts the way that he does and build exactly the same bridge that he builds. That's why we're calling it a build along. We think that this is going to be beneficial to everybody in the future that is a model builder, and particularly for small manufacturers who may be able to start doing the 3D design themselves rather than having to pay somebody else to do it. So with that said, Earl Hackett, welcome.
Hey, how good to see you all. Okay, I going to start with a PowerPoint presentation. I'm going to share screen here. And let's see, play from start. How we do what? I don't want to see screen two. I want to see this one here. There we go. Can you all see that introduction slide?
No, it's not sharing.
Share screen. Oh, share.
There we go.
Okay, here we go. Now, can you see that one?
You darn right.
Okay, very good. We're cooking. This is going to be an introduction to the system I'm going to be using. Now, one thing you have to realize is that once you learn one CAD system, you can very quickly pick up any of the others. My preferred system is called Rhino. It's a combination of surface and wireframe and solid modeling. It's what I prefer. But I went through a bunch of free systems that don't, and they're quite competent. They're very excellent systems. And I selected one because it has some characteristics that are great for teaching. There's some software you're going to have to download, and because you're going to want to capture some information that I'm going to be presenting. And what I found works well for me is Screen Recorder Pro. It's a means of taking screenshots if you die, or recording an entire video of the presentation. And at the beginning of each presentation, I'm going to show you images with the dimensions of the parts we're going to be building. And this, I'm going to be building it in HO. So if you're going to be building it in no scale, you're going to have to up the size a little bit. And you probably have to make sub-assemblies so that you can get it into the printer volume. So as a minimum, you're going to want to have copies of these slides for reference as you work. And it is a free download from the Microsoft Store. This is what its little operating window looks like. And I have two screens on my system. So I'll be working on my primary screen, which is what you're seeing. And this little guy is going to be on the secondary screen along with a bunch of other stuff that I find useful to have handy. But what you're going to want to do is you're going to want to select full screen, this guy right here. And you're going to want to make sure that you select the folder. If you don't select the folder, you don't know where it went. It can go just about anywhere. And there's another little thing here called configure. And configure lets you set up some hotkeys. For example, if you only have a single screen, like we're sitting here, You could bring up set this up, and to trigger it, for example, to get a screenshot here, you just print your print screen button, and it'll take the screen image and it'll store it wherever you have it set up to store it. You don't have to go through print screen and putting it in Paint, and giving it a name and putting it somewhere. This thing just grabs it and sticks it there. If you want a full recording, you can, this is the default, it's alternate F9, and it'll record the whole presentation. Now, you don't really have to do that, because I'll get this thing back up on YouTube in the next day, or do a day or two after we present it. Now, I looked at a bunch of free CAD systems, and some of them were pretty pathetic. But there were three that stood out as being really worth examining. And I had real high hopes for FreeCAD. It's open source, easy to use, but it has some bugs. Yeah, these guys have been working on it for years. It's much better than it was when I looked at it 5 or 6 years ago, but it still had some bugs, and I felt uncomfortable using it as a teaching system. Fusion 360 is also an excellent system. The only problem with it is the interface. It is at best confusing. It has all these little pop-up whirligig things that show up, and they can really confuse you. Now, can you see the little side screen over here with me at the top? Well, I don't know.
No,
No, you can't. Okay. It's not sharing that part. Okay. But I did print the main girder from it. When I get done with this slideshow, I'll show you the parts. It's functional. It works well, but I would spend more time trying to explain how to use the system than how to build the model. The real problem with CAD is looking at a structure and figuring out how to break it down into pieces so you can easily produce it in digital format. OnShape is also an easy to use interface. The files, and both Fusion 360 and OnShape, your files are stored in the cloud. They're not on your computer. But OnShape is unique in that the files are stored on a free service, what they call for OnShape for makers. The files are stored on a public server, and I can go in and take a look at what you're doing. And if you're having trouble, I can look at the history, and possibly I can figure out where you went wrong. So that makes it great for instruction. Fusion 360, the free system cannot be used for commercial purposes. If you want to use Fusion 360 for commercial purposes, you have to buy a subscription, and that is $500 a year. I don't like subscription services. OnShape, there is no restriction on the use of the files, even on the free system, but they're stored on a public server, and anybody can download them and do anything they want with them. It's considered public property. So that's how they control people. That's how they get people to want to get into their paid service, because that's in a private server and only you have access to it. That service is $1,500 a year. That is way out of my price range. So the public server is great as far as I'm concerned. Now, the one thing about Fusion OnShape, you don't download anything. Everything is accessed through a browser. I use Chrome. This might be a little strange for you, because you bring up OnShape and heck, you're running the doggone system through your browser with a mouse. So this is their home page. When you want to set up an account, you scroll down to the bottom of their page, and way down at the bottom, and I mean it's way down at the bottom, you'll find sign up. Excuse me. You hit sign up.
Earl, let
Yeah.
me ask you a question.
Shoot.
how do you get it on your computer to start with? I know you say it's a browser. I have no idea what a browser is.
Oh,
So
browser is just,
how do I get this on my computer?
you just use Chrome or
How
Foxfire.
how do I use Chrome?
Do you go on the internet? This is just like
Okay.
visiting an internet page.
So,
I'm going to demonstrate it. I'm going to demonstrate it before we're done here.
okay.
I'm going to actually go on
So
there.
I type something in, like, for example, if I go to Google and I
Mhm.
type, what do I type in Google to get to this page?
When you set up an account, you're going to have OnShape. It'll be a tab on your browser. It's
Oh, okay.
it's right next to Google on mine. You
Okay.
click on that, and boom, you're in it.
Okay.
I'll demonstrate that. You're going to see it. It's really
Okay.
simple.
Okay.
But you go to sign up, and you click that, and you come to this page here. And this is for the professionals and education. You want to go to OnShape for makers. Down just below that, you click on this one. And you come to this page, OnShape free. And it says get started. So you click on get started, and you come to the setting up your account. You put in your name, first name, last name, email, describe what you're doing. You're going to put in a password and all this other stuff. It's just like setting up an account just about anywhere. Once you set up the account, you come back and you click sign in. And this is the Google. This is my Chrome page image. You click sign in, and here it is. This is the bridge that I designed. And the first page you come to is, you'll go through a sign in. It says, okay, sign in, put your name and the usual sign in stuff. But this is what you see when you get in there. This is what they call the sketch page. And it has certain things. The ones that are important that you're going to use are line, center point, rectangle, center point arc, trim. We'll talk about that in a few weeks. Dimension is very important. Coincident is very important. And then these are restrictions. These will, if you have a line, you say, I want it to be horizontal, you can click it with this, want it to be vertical. I find these pretty useless, but you need to know that they are there because they're going to give you indications to what's going on. Once you have a sketch created, come down here. These are the ones you really want to look at this week. Line, rectangle, center point arc, dimension, coincident. I'm going to demonstrate these things. And what you need to do is get yourself an account and play around with them. I'm going to show you how to do that in just a few minutes. Once you have a sketch, you're going to say, okay, and it'll bring you out of the sketch and you come to what they call the solid menu. And here you can extrude it, you can revolve it, you can thicken it. That's a strange little thing, but it's really handy sometimes. You can make a linear pattern for arrays. You want to roll rivets, that's where you go. Mirror, union, and transform. I'm going to demonstrate all these things in just a few seconds. The solid tools you're going to really want to practice with is extrude, revolve, linear pattern, mirror, Boolean union, and transform. And they're very easy to use. And we're going to go through the lesson topics we're going to go through. First week is going to be the main girder, the outside stiffeners. We're going to go the second week, we're going to mirror the stiffeners to the inside and add cover plates with rivets. Then the next week will be floor beams and stringers. The fourth week will be cross bracing, and fifth week will be 3D printing. We'll show you how to set up the printers, set up the supports, and I'll show you, I'll run the printer. One of the things I'm doing is I've set up in my email account, I have set up this email address, this email, I don't know, it's an email address. You can write to me with any problems you have. And I'll do my best to get back to you. This is the nice thing about OnShape is that your files are all stored on a public server. I can go in and I can look at them and I can look at them in detail. But for me to do that, remember to save your work under a unique name so I can find it, because there's thousands of images in there. A lot of people use this thing. Okay, time to kick the tires. Let's turn this off. Okay, now I'm going to bring my, where'd he go? Here it is. Okay, I need to blow this out to full scale. Come on, Zoom. I just want to show. This is good. What are you seeing right now?
White paper right in the middle.
Oh, it says Zoom United, and Zoom join meeting.
Okay, wait a minute. Here, wait a minute.
We're seeing your screen.
Okay. Am I expanding
Just
stuff
make
right
that
now?
full size. Make that full size. There you go.
Yeah, there we go. Okay. Blow this up. Here's Google. This is OnShape. This is the tab. Once you set up your account, you'll see this tab up here for OnShape. We'll click OnShape and you go to sign in. And I'm already signed in, so you didn't see the sign in screen, but you'll have these are little projects that I'm working on. Now, this one is an empty project, and that's what I'm going to use to demonstrate some of the stuff. Okay, this is an empty screen. This is what you start with. Can you see this box here, all this stuff? See that rotating?
Yes.
Oh, good. Okay, that's great. Okay, so let's go to the, I'm just holding down the right mouse button and scrolling it around, and you can rotate this thing anywhere you want. If you want to bring it up to a particular surface, here's back. And of course, front, this is the back, so the front is shown backwards. Left, front, right. I'm going to go to the right side because it's convenient. Now, in any of these solid modelers, you're required to do a sketch. A sketch is just a bunch of lines that show an outline of a thing you want to build. You are required to put it on a plane, a defined plane, which in this case will be the right plane, or on the surface of a part. And I'll show you how this works. So let's say we want to do a sketch. You're going to click Sketch. Sketch plane. And then what it's asking for will be in a blue square like this. And you just click the plane. So it says right plane. So we're all set to draw something on this surface. And you can select any of these tools up here, line, you can select any of these sketch lines. Well, I'm going to just go here and we're going to get a center point rectangle. And you just draw a thing. Now, these are the dimensions that it currently exists. I want to make this a square. So I can come up to the constraints, which are up here, come down, and it says equal. This one and this one, I want them equal. Now I have a square. That's pretty simple. Now I have to define what this thing is. What is the size of it? You saw that it had dimensions, but that may not be what you wanted. It probably isn't what you wanted. So they have this little guy here called dimension. You click on it, drag up the dimension, click it, and now you can enter whatever you want. Unless for a nice number, let's call it 50. And I always work in millimeters. Hit enter, and now you have a 50 millimeter wide and long square. Now you notice it's still blue. It knows what size it is, but it doesn't know where it is. And so what you're going to use is this coincident tool. And what this does, it makes 2 points the same. Here's the center of the square, and this is the origin here. I'm just going to click this one and click this one. And now it's centered on the square. So it knows where it knows the coordinates of all these points. It knows it's at the center, and you notice that the lines turn black and the center is grayed out. So that's all there is to it. I now have drawn a square. Now I want to make it into a box of some sort, give it some depth. Well, you come up here and you say, okay, I'm happy with that. You check the little green check, and notice up here, the commands have all changed. These are the solid commands. And you can do a variety of things with this, but I'm going to extrude it. So we just click, this is extrude, this is rotate. These are weird things you don't need. And I probably want to, I think I'll be using chamfer eventually in this program, but right now we'll worry about that later. Click extrude. Faces and sketches to extrude. What do you want to do? Well, that's what I want to work with. So it says sketch 1. Depth 25. This is how deep you want to extrude it. Well, I'm going to make it 20. That's a nice number. And this is something that's important. These options down here are important. I'm going to say symmetric. And what that means, I'm going to show you in a second. It just created I think it was 50 by 50 by 20 rectangle or rectangle. Now I can rotate it around, and you'll note that the center is right in the middle of the rectangle. That is really important later on. So you want to be aware that if I didn't select symmetric, it would just extruded it right straight out on the face, on the right face. In other words, it would be displaced from here over to here. Okay, so there we now have a box. Let's look at it in the front. I'm going to put a sphere on this thing. Now, you'll notice that there are no spheres. These are solid commands, but there's no sphere. A sphere is going to be a rivet one of these days. So what I have to do is I have to go to sketch plane, but I'm going to sketch on the surface of the box. So it says face of extrude 1. I'm going to put a sketch on this surface, draw some lines on this surface. And we're going to take what they call a center point arc. Now, I'm going to zoom in here. And you're going to see something. When I come down and come close to this, look at this that little box that's down the lower, just down and to the right of my cursor. That little dot in the center of the line means I'm on the center of that line. You want to be aware that you can put on the center. You can put it over here on the corner, or you can see as soon as I'm attached to the line. If I come down here, it disappears. I'm just somewhere. And we're going to put it on the edge right here in the center. And now we're going to create a center point arc. Now I notice I keep my cursor on the edge. I click 1, and I put it on the edge and click 2. We now have an arc. Radius of 2.1. Well, okay. I'm going to measure it. I'm going to set it to a radius of, and again, you just click on the thing you're interested in, and you drag the dimension away, and now with this highlighted in blue, you can create whatever you want. Now remember, this is the radius we're talking about. So if I wanted a 5 millimeter diameter gizmo, I type in 2.5. Now I have a 5 millimeter. Well, that's one. Remember, when we work with CAD in these systems, you have to have a surface. Where we have one line, that does not define a surface. So we come over here, we pick up the line tool, and we connect these two ends, there and there. Now those two ends are all defined, so that defines the line right away. And I'm happy with that, so I click check. I'm now going to take this and I'm going to revolve it and turn it into a sphere. So we're up here again. We've gone back to the solid tools. Revolve. Now here's this is a stinky little surprise it has for you. It says faces and sketch regions to revolve. So you click the region you want. And now it says revolve axis. Well, everything's fine so far. I said, okay, I'm going to use this line that I put in there as the revolve axis. So when it revolves it around, it becomes a sphere. Okay, look at that. The stinker moved it, made it add. If I click OK now, this sphere and this rectangular thing is going to be one part. I want to keep it as two parts. So I come back and I say, no, you stupid thing, I want new. Now when I say OK, I have two parts now. Part one is the box, and part two is the sphere. Oh, I hate that. Stop that. Okay, so because this is a separate part, I can take part two and I can move it. Now, when you move something, it is relative to whatever point you select. For example, this is where I can use the thing called a transform. This is part two. I have part two selected. Says, okay, lines or points? Lines or points? I'm going to do that one. This allows you to select places to move it. So for example, I come down here, I can select the middle and move it from there to the corner. And if you like that, you can check the box and it'll be there. But you can also copy the part. And now I'll have two. Oh, that's nice. Part three is over here. Maybe I don't like part three, so I can delete it. Just hit delete on the keyboard. It says delete part three. Yes, delete part three. Boom, gone away. Now, it's still in its memory bank, but it's not part of the part anymore. But the other way to get rid of it is just to delete the transform. And for example, let's see, delete, and it comes back. Now I'm going to delete the transform, delete, and it goes away. I'm back to where I started. So you can always back up through this history. If you don't like what you did, just back up and the problem's solved. So let's look at the right side for a minute. I'm going to do another sphere. I'm going to do a sketch. We're going to on this surface here. Sketch plane, it says, okay. Face of extruded one. This is face this time, little different face. And I'll come up here and I'm going to select my center point arc again. And I'll put it in the middle and we'll go boom, boom. This is going to be a little one. Radius, let's make the radius. Go up here, measure. I'm going to make the radius, I think, 0.2. I'm going to make a bunch of rivets. This is a little bit, 1 inch in HO is about 0.3 millimeters. So this is a little bit bigger than a 1 inch diameter rivet head. So we have to make this. We need a surface. It's not a surface yet. So we'll go over here, pick up our line tool. Okay, and we say, that's fine. We're going to go to revolve. We're going to revolve this, revolve axis, this. And again, it wants to add it. Well, we don't want that. We're going to stop that. It's going to be new. Okay. We'll go to transform. Now, and select entities. You can select them down here too. Liner points. This is where I probably don't want that. So let's translate by X, Y, Z. Now here you get to put in a direction, a distance you want to travel. Well, what distance do I want to go? Well, first you take a look up over here, and this shows you the Z and the Y axis. Those are the ones are available to you. You can also do the Z axis, which is in or out of the plane, but that's we don't want to do. I don't want to do that right now. So we're going to take the Z axis here, and we're going to set this to -1. And we're not going to copy it. We're going to say, that's nice. Boom. So this is still a loose part. But now I want a row of rivets. So what we're going to do is go to this guy here, linear pattern. And entities to pattern. I could select it here, or I could select it up there. It doesn't matter. Direction. Now this is a little misleading. There's several ways you can show direction. The most obvious is to select a line over here, which says, I'm going to go basically up and down in the Z direction, or the Z direction is here. So it's going to go up and down in the Z direction. The distance is how far you want them apart. 1 millimeter. How many do you want? It's a pretty big thing. I'll take 15. No, not 165. No. 1.5. Go all over the place. And hit enter. Oh, no, that was really neat. They went up. Not a problem. This is what the arrow's for. Push them back down where they belong. You now have a row of 1-inch rivets, 3 inches apart, or thereabouts. Now, if you come over here, you look, we have all these parts. Now you can, I'll tell you what I'm going to just join them. We're going to take, nope, no. I didn't tell it I didn't tell it I was happy. I make mistakes. I'm new at this thing. 1 millimeter, 15. Enter. Shoot. Where are you? Okay, well, easiest thing to do when you screw up, come back here and go linear pattern, delete, boom, fixed. We'll try it again. Linear pattern, entities to pattern, 3, direction, that way, distance, 1, number, 20, enter, fix the direction, and check. Got it right that time. Okay. The problem was I went to select them and I hadn't checked it, so it didn't know what to do with me. So let's take all those, selected all those, and part 1. And we're going to union them. So let's see what we got here. Part 15, 17, 8. I get them all. Part 1. Okay. Boolean union. We're going to union. It's going to take all these parts and make them into a single entity. Check. Now we have part 1, which is our original sphere here, and part 2, which is everything else. Well, let's take part 1 and 2, and we'll union them also. So everything will be one part now. So go to union, part 1 and 2, check. Okay, this is one part. Now, When I built the original, and I'll show you the original, I started with Fusion 360. And I built the main girder by drawing a 1/8 inch portion of it. And I mirrored it back and forth and over and under to turn it into the full size girder. And you do that by going over here. So we have rivets on this side, this guy here, just to keep track of where I am. So I'm going to mirror part 1, mirror plane, this surface here, check, boom. And what this has done is taken these rivets here, they're on that side, mirrored the whole thing. And now you'll see the rivets are over here too. It mirrored the whole thing. It's still only one part. Now, if I come under here and I do the same thing again, I'm going to do it a little differently. Mirror, part 1, mirror plane here. See, well, he switched that over to the ad. They love to do this. I'm going to make it new. So it's 2 parts. Check. And now you have these 2 parts with everything there. So just for the heck of it, I'm going to look at the front, stand that up right. I'm going to take part 2, and I'm going to move it from there to here. No, I'm sorry. I didn't move it. Transform, yeah, transform. Part, not one, liner points, okay. Liner points, I'm gonna go from here to here. And that's good. And I'll take parts 1 and 2. And we'll union them, put them together. Check. Now I have a single part that looks rather strange. But you can see that you can move these things around. It's not a complicated thing to do this kind of work. And I'm going to get out of here. Okay. Put me on the screen. Oh. Could you get me
I think
Okay.
if you hit join, it'll do it for you. Sign in or whatever.
oh,
Or I just stop your share.
Or stop share, yeah.
okay.
You're already logged into Zoom.
Stop share. There we go. There I am. All right. Okay, here's a couple things to show you. This is the, see if I could get this in focus. This is the girder I did in Fusion 360. And it came out all right. Fusion 360 does work. It works quite well. This is the girder bridge that I printed out of OnShape. It's a through girder bridge. And the detail is really quite astounding. This is printed in one piece. In HO, I have a Saturn Saturn printer, Elegoo Saturn, and this just fits on the build plate. If you're running in O scale, you're going to need a bigger printer, or you can print individual parts, like in an individual segment like this, and then glue them together. There's a variety of ways you can figure out how to break it apart and build pieces and make a kit out of it. But as you can see, we have all the interior detail, ribs on the inside, ribs on the outside, cross bracing. The cross bracing is a bit tricky. That took me a while to figure out. And it's pretty unique to build that stuff. So that's the last thing we're going to do. So what you really need to do is to get a copy of OnShape. Get sign into OnShape. You don't get a copy of it, just sign into their website. And you want to do what I was just doing. Just make boxes, make little spheres, linear patterns. Just get to know the tools, because you have to be very familiar with the tools before you start tackling something as complicated as this. you don't want to be trying to figure out how to use the tool when you're really trying to figure out what do I do with this thing, because you can't build it in one piece. It's a sequential construction, and you have to know, and that's what I want to really bring out, is how to break this thing down into logical sequences so you can take a look at any structure and see immediately how to break it down and into manageable pieces, and then assemble it all in CAD and be able to print it out in a single piece or as a kit. Some of my parts, like my signal towers and things, they're kits. The roof is one part, the body's another, has a chimney in the back, steps are another part. And you build them all as individual pieces and put it all together. Let's see, what else? Oh, one other thing. I'm going to go real quick. I'll show you Rhino some other day later. Right now, let's not worry about that. But I do want to demonstrate Rhino because it is it's a permanent license. You pay $1,000 and you get the permanent license for the rest of your life. Not a subscription, at least not yet. It may turn into a subscription service when they run out of upgrades. But the upgrades, they're putting stuff in there now that I don't understand. It is really exotic stuff, and I'll never buy another upgrade from them. So I'm just going to sit with Rhino 7 and use it for the rest of my life anyway. Okay, any questions?
Earl,
Yeah.
in a later lesson, are you going to discuss how to download your file in CAD that you've created
Oh yeah.
and be able to send that to a third party to do the actual printing, so we don't have to invest in
Oh
a
yeah.
printer and resin and
Oh, yeah.
all the other good things to make our project?
Absolutely. Actually, OnShape makes it very easy. You go and ask it to generate an STL file, and it's slow. You're going to push the button, and it's going to sit there and hum for several minutes. But eventually, it'll spit it out, and it goes to your download folder. And then you just take that file and send it to Shapeways or whoever you want to send it to, just as an email package, email attachment.
Thank you.
Jim, I might mention at this point, we have a company that's owned by David and Kristen Kimmick. It's called 3D as in David, P as in Paul, trains.com. And they do 3D design and printing. And they're going to offer a 10% discount off of their print costs for anybody that is building along with Earl. Now, what you have to make sure of, however, is that the print you send them is what you want printed. And Earl can help you make sure that your print is going to deliver what you think it's going to deliver before you send it to him. And that'll be down the road before he goes into, this is how you send the print to somebody. So this company would be an alternative to Shapeway, an alternative to somebody that you may find is a friend that lives close by, that has the kind of printer you need and can print what you need done, and will do it for you off of his printer. But if you can't, and you're looking for a company, at least this first company that we have found will give everybody a 10% discount for the parts and so forth that you're building along with the Earl in this series.
Okay, so what you want to do, and I can't stress this enough, you want to look at those few tools that I showed you today on that little quick demo, and kick them around and just mess with them. Just push things around and just do all kinds of crazy stuff so that you get to know how they behave. There's some options in there that you can play with, where you can copy or you don't have to copy. You have to watch that thing always wants to go to add, so it takes your new part and sticks it, so you can't do anything with it. So you have to watch out for that. But other than that, there's not much really complicated environment there. It gets more complicated when you start looking at rivet patterns, spacings of stiffeners. You have to, it gets a little more complicated then. But this particular model, being a 50-foot girder bridge, the numbers come out very nice and even. You don't have lots of little decimal fractions that you have to worry about. So everything is pretty much whole numbers of millimeters. So with that, if anybody has any questions, I'll be glad to tackle them. But it's really important to be able to handle those tools, the sketch tools and those few solid tools. And it has to be just instinctive. If you make a mistake, you can always back out, but mistakes can get to be really painful if you don't catch them soon enough, because you may have to back way out. I did that a couple of times. Oh, one other thing. I did all the drawings for this while we were on vacation in our RV. My communication to the internet was through my 4G phone hotspot. And I saw no difference in performance with that versus the Fios high-speed internet that I'm working on right now. So the band, you do not need a huge bandwidth to use their system. I was very surprised that out in the middle of the Ozarks, we could I could access it without any trouble at all. Okay, anything? Okay, well, get yourself an account, and the next time around, we'll start actually building the main girder.